Hey everybody, this is Tim, back again with another video, and in today's tutorial we're going to learn how to build our own Popcurveforce in Vex, so our own implementation of that. So if you don't know what it is, there's a node in DOPS called Popcurveforce, and essentially it's a node that allows you to put in a curve, and then particles can follow the curve. And if you've ever used it, you know it's notoriously difficult to control. Particles will often like lose track of the curve and then just go and fly around, and it's especially annoying if you have like really long curves and you want like your particles to really like follow a specific trail. So anyway, I was working on that with it again, and well, I ran into all of these issues again, so I figured I'd just make my own sort of implementation of it. Not as like it doesn't have as much functionality as the original one. You could build it out to have the same functionality. But in my case, I just wanted something that sort of would follow long curves without losing track of like whatever it is they're doing. And then I was working on that, and I figured, oh, this would make actually for a pretty interesting tutorial, I think, because it covers some interesting concepts that apply to this if this is specifically what you need. But it also covers a lot of concepts I think that are just really interesting overall, so you can apply them to other things in your work. So yeah, I guess let's dive into Houdini. Before we do, like, if you want the source files to this tutorial or other tutorials, you can get them on Patreon, so they're available for my Patreon supporters. My Patreon supporters help me make this content as well, so if you wanna be part of it there, you can do that with the link in the description. I also put them on Gumroad if you just want to get the files one-off. Either way, you're helping out the channel, so thanks a lot. And yeah, anyway, without further ado, let's just dive into Houdini and just see how we can build this custom implementation of a Popcurveforce. Right, so here we're in Houdini, and like essentially we're going to be making this thing. So this is a slowed down cache of my original sim. So I simmed it, but then I slowed it down later. But so now it gets this nice slow magical thing. So this is what we're going to be building from scratch, including some like the rendering stuff. In Mantra this time. Normally I will do everything in Redshift, but yeah, like this additive rendering, Redshift doesn't do that by default. So and particle rendering is pretty fast in Mantra. Anyway, so here's the thing. So I have a curve here. Let me just remove this thing. So I have a curve thing. Let's just have a look. Let's play, and you can see some particles. They're moving past the curve. Nothing too special, but that's what they do. And well, they die at the end of the curve, so that's also something I built into the setup. And then I cached it out with a lot more particles for the final frame. Of course, you can see it's 22 million particles per frame for the final thing. It's a pretty hefty cache. Let me check. It's like, oh, it's 80 gigabytes. That's the thing with particles, like you need quite a lot. But yeah, anyway. Then later I slow them down, and then we have the slowed down version. So anyway, here is the one with few particles, and here I have the same thing here in DOPS. And if I just play through this is this is with the Popcurveforce and that thing. So this is Popcurveforce that like has a whole bunch of options, like to change the curve here. Let me just turn off the guide, so you can see if I just have it like this configured properly, there's actually not a problem here. So in this case it works fine, but a problem arises. For example, let me see if I can force this, because like in this exact example, the Popcurveforce works fine, to be honest. But let's say if I make it like small enough that the couple will sort of flow out of it, or let's say I make it big enough, and let's say I really increase the speed here. Let me just maybe do it a little bit less extreme. Right, let's try to force them out, because the problem arises when they move out. Yeah, you can see it here. So once particles sort of go out of the radius, they start sort of free floating here. which can be really annoying, especially if you have really long simulations. Like I did something like a couple of years back, and I was like really, like I had a couple of, like I needed to make a couple of minutes of particles following a trail, and there it was especially annoying. That time I solved it way different because I didn't know enough about Houdini back then to come up with a custom solution like this. But anyway, that's essentially that's a problem that like that you will run in with this Popcurveforce. So you can see, like you can see here, it will just go completely crazy. So I have my own implementation thing here. Let me just play this. So let me try cranking up the speed. See what it will do here. It will probably start looking weird after a point, but yeah, because like when they get too fast and start looking weird anyway. Maybe if we decrease the section. But all right, yeah, you can see. So here it's still following the thing. It's moving quite fast. It has a larger radius. You can tweak the radius, but we don't have any free floating particles. So they will still, even if they move pretty fast, they will still sort of follow the rough sort of curve, if that makes sense. So you won't, like, even if, like, probably if I crank it up too much now, it will completely start acting really weird. It's not even too bad, but anyway, you can see they won't start free flying. Yeah, there's a couple of lines of vex. We'll get into it. I'll try to explain everything as simple as I can. But again, it's not a super beginner tutorial. Like, you will need to understand like the basics sort of some vex stuff. Yeah, so let's start building this, and let's make just an empty geometry node and just explain some core concepts first that we need to understand. Curveforce. So let's explore some core concepts that we need to understand in order to be able to build this thing. So let's do that. So the function that we're going to be using is primuv and xyzdist. And I think a good way to sort of maybe first start explaining this, if you have ever never used them before, they're super useful functions, and you are gonna, like, you use them quite a lot in Houdini. But let's first just make a sphere, and let's make a pig. And let's make a trusty old piggy. Let's make it a little bit bigger. Let's remove the shader. And let's first scatter some points on this sphere here. Scatter, whoop, and maybe a little bit less. And let's put array. So you've probably all used array at some point. So put array and then put it to minimum distance. So if you've used it for any period of time, you've probably used array before. Essentially that's part of what we're going to be explaining. So what array will do here with minimum distance, it will look for the minimum distance to a surface and will project this point on the surface where that minimum distance is. So that's just a Houdini sub tool here. We can also do that in vex, and there's a very simple vex code for that, and that is, you might have even used that. This is called min pos. So if we say the position is going to be min pos, so the minimum position to the first input, and it's always, yep, it's like that. So at p, so this will do the same, as you can see. So this will project it, and I can probably even show you if I do array on the side here with minimum distance. You see this does exactly the same thing, projects them to the minimum position. We're not going to do that as well. There's another way, and a more versatile way than using min pos, and that is primuv. So essentially, what we're going to be doing the same sort of concept. Let me just very quickly on it. What we're going to be doing is we're going to launch an array from our points to a second input, to closest thing on the surface. And then we're going to extract an attribute from that part of the surface. And like when you're thinking of UVs, you might normally be thinking of like these types of UVs. That's not where we're going to be. Like, it's how I kind of imagine it. I'm not sure if this is a good explanation for it, but like every primitive like has its own sort of coordinate system thing, and they all have, so I can have like primitive this, and then within this thing, like there can be attributes on here, and there can be like this within this little coordinate system, there can be a position, etc., etc. So each of these things has their own little coordinate system. We can look into that little coordinate system, and then we can extract stuff from there. So, okay, which position do you have, which color, which whatever. So, and then we can extract more than just the position. So let's just first just set that up. So first what we need to do is we need to create some holding variables. Let's call integer myPrim. And again, you could call this mycheese as well. Like it doesn't matter what you call it, but myPrim probably makes sense because we're gonna talk about primitive. So it's going to be holding, and we're only need to do a holding vector. Let's call it myuv or something. So that's going to be the holding variable for the primuv thing. And then we're gonna be using a function called xyz distance. Boop. Let's open up the help file for it. Right. So it takes a geometry. So first input takes a position input, and then you can see this ampersand thing. I think this is ampersand, right? in English, we in Dutch we just call it the n sign. Anyway, this means that it's a function that can pass through information to another function. So that's going to be the primuv function we're going to be using after this. So anyway, we're going to be putting these holding variables here. So myPrim and myuv. So those will now be containers for whatever it is that we're going to be asking from it. So these will pass stuff through another function. So now we can ask myPrim and myuv, like, hey, you have been projected onto the little surface thing here. Boop, boop. What do you find on your surface? Like it's you're sending an excavator there to like dig for attributes, kind of. All right. Anyway, that's where xyz distance comes in. xyz distance, and sorry, not xyz distance, where primuv comes in. Boop, boop, boop. Right, comes in. Let's open it. And this will actually write out to an attribute, so we need to put something before here. So let's say, for example, vector, let's call pulse. Because we're gonna extract a vector and just call it pulse. Just like we with the so if we were to do min pulse, you could also do vector pulse and then min pulse, and then would hold the minimum position value. In this case, we're gonna extract something from the xyz distance. We're gonna again do it from the first input thing. Which attribute? Let's do the position. Let's drag the position. Which primitive? Well, that's going to be myPrim, because that's the thing that the holding thing, and myuv. All right. Boop. So now we're extracting the position there. And then if I say at p equals pulse, boop, you can see again, we're doing exactly the same thing. So if we just switch these back and forth, and now I say, yo, that's cute, dog, but we did exactly the same thing. Well, the cool thing with this is that we can like we have this function where we can put other things here than just position. So if we put color, so let's say I put a color on my pig, and let's make it random. So let's do a random color. I can just copy and paste this line here. And I don't necessarily need to do it like this. I could also just say at cd equals. So in this case, all right, let's have a look. And you can see now my points here inherited the color here. And again, like this can be any attribute. Like you could make an attribute called cheese and extract the cheese attribute. You could extract anything you want. So it's just a really cool way to sort of look at another primitive and extract the data and then do stuff with it. And this is going to be the basis for our custom sort of Curveforce thing. So this is already pretty useful. If you didn't know about primuv, xyz distance primuv, then now you know, and it's super useful. So this is what we're now going to be using to build our little Curveforce. So yeah, let's start doing that. All right. So let's draw a curve. We have something to work with. And let's just do something like loop-de-loop. All right. Let's first make it a little bit bigger, because I already know that this is going to be a little bit on the smaller side. So I guess something like this. Let's smooth it out. Smooth, very smooth. Let's resample this, and we want quite a lot of points. Or maybe let's first edit it and then later we'll resample it, because we do want this to, all right, just do a little bit like this, all right, something like that, and maybe, all right, something like this, I guess. And then to resample it, if we do want like quite a lot of points on this, because it's going to be sampling these points, right? Maybe something like this should be fine. All right, so we're going to be making, maybe I don't like the sort of that last little thingy. All right, so let's do it like that. So what we want to be doing is we want to have thing follow our little curve. So if we were to like, so let's make sphere. Make it a little bit smaller. And why are you not even showing it? Right. So let's move it into position. So it's like right on the curve there. And let's do a pop network. Boop, boop. Let's put in second input. And normally, if you were to do something like this, you would use a Popcurveforce. Again, we're going to be making our own, but just to show you normally what you would do, you would put it in, you have the influence radius, and you would. All right, so we probably, so it's going the, so we need to put the follow scale to the other direction. Let's turn off the guide. And you can see now it's following it. We probably want to be a little bit faster. Let's do -5, 3. So anyway, yeah, so now they're going to be going through the curve thing. All right, and you can see, already see a couple losing track. So build our own, but anyway, this is what we, you know, that's what yeah, what you have normally with this thing. So let's just disable it. Yeah, so build our own little thing. So we need an attribute on this thing. And by the way, let's already enable on this resample, by the way, also curve view, because we need curve view. So curve view is an attribute from 0 to 1 across the entire curve. If you watch Houdini 101, you know all about it, or any of my other tutorials, because I use it all the time. And what I also use all the time is coffee. So let me accept. All right. So first we need to have a direction to this curve. And easy way is just do polyframe. No, polyframe. And then this is gonna compute the tangents. So the tangents are just gonna be in the, the direction across the curve. So here you have tangents, you have normal. If I just put, for example, my normal where the tangents are, then I can visualize that. So you can see we get, so it's essentially just kind of sort of a vector pointing from one point like to the next point, kind of just going around it. Yeah, so there's a tangents of the curve. So now we have a direction. I kind of feel that they're going in the wrong direction. Does it? Oh no, they're going in the right direction. Okay. Either way, it doesn't necessarily matter that much. We can just change that in the wrangle that we're going to be doing. So now we have a direction. So that's perfectly fine. So let's go in here. Let's just remove this Curveforce and let's do a geo wrangle instead. Geometry wrangle. No, not a VOP. Geo wrangle. And let's also just grab our thing over here on the right as a reference. We're going to be typing it again, just so you kind of do it again and then you kind of know what's going on. because I mean, I can copy and paste this, but again, I think repetition is probably good if you want to learn. So let's do another one. Let's do just, oh, by the way, before we do that, let's in inputs, first input, just want to run it on the current input stream. So myself, and then second context geometry, that's going to be the curve, right? So that's going to be the second input geometry. All right, so yeah, let's start. So just left side parallel functions again. So integer my prim, integer, oh, vector my uv, xyzdist, 1. Let's grab position my prim, my uv. All right. So from here now we can start extracting some stuff. Now your initial thought might be, all right, let's extract the normal, so the vector, and then just add it to force. But let me show you what happens if we do that, because we need to do something else first. So let's say vector, let's say n or something equals primuv 1 p, oh, p my prim my uv. All right, and let's add this to force. So force is going to be pushing stuff on the things. I'm going to explain more about it in a little bit, but at force plus equals n. All right, let's see what's going to happen. So let's check this and let's press play. All right, so first off, they're doing the wrong direction, so we probably need to, oh wait, we should extract n. Sorry, not p. All right, so let's press play. So they're gonna move in a direction, and then they're gonna overshoot. So what's happening here is that it's extracting the normal, it's applying it as a force on the points, and then they're gonna move, but then they get here, and then they sort of already have velocity going that way, and then they get additional velocity over here, but we don't have anything to tell them to sort of really just, if they get here, to like to go like to move out of the way and just really make the curve. So now they just get some force added, and then just get something like this. So we need a second force to sort of pull them towards the curve. So let's just make a setup for that just in SOPs to just explain kind of what's going on there. So let me put sphere here. Let's get a couple of points on it. And let's do a wrangle. And let's do vector pos equals min pos 1 and p. So just min pos, then we don't have to like make this entire thing. I just want to draw a vector from these points to the curve. So I'm just going to say at n, just to visualize as normal. We could also call it something else, but this already has a visualizer. We're going to say at p minus pos, and we should probably invert that. Right. So you can see we now have a line moving away from the curve. So I'm going to put this in between brackets, cause order of operations, because we first don't do subtraction, and then multiply it by -1. So they move towards the thing. So if we now, let's just do a transform, by the way. A little bit easier to move. Right. So if we now move our thing, you can see, well, so it draws a vector now to the curve. We could add a multiplier in between here. So I guess we could just say here this times multiply. So this would be the amount of force that we would get. So you can see we generate a with this thing we generate a force that's pushing it towards the curve. It doesn't matter where this thing is. So then we have a second force. So two things that we're gonna do in the dot network. We have one force pushing points towards the curve. So then they will sort of move to it, and the further away it is, the longer that vector will be. Because you can see if I really move it out of the way, you can see it will get really long. So it's just sticking to wherever it is that we're pointing it. So that's the first thing, pushing it towards. And then when we have that, we're going to add the other velocity. So that's going to be the direction of the curve. Let's go there. So we have this thing. And maybe we should just call this direction. Let's remove this thing. And so let's copy and paste that. And let's extract the position. So the thing I first did wrong. Let's call this pos for position. And then we're just going to do again what we did here as well. Only now with a, I guess we could just copy and paste. And this thing that we have over here. Or just let's just write it again. So we're going to say vector maybe push or something equals at p. Or that's between bracket at p minus pos times equals 1 times minus 1 times channel float, and let's make a let's call it suction or something. Or maybe call this thing also roll suction because it's sucking it toward the center. That's also what I called it in my original thing. Right, so now we have a multiply here for the suction of the thing. So if we were to now say v at force plus equals suction, and if we just play, you can see them moving towards the curve. Probably if we move this a little bit out of the way, it's a little bit easier to see. So you can see, oh, they get sucked back, so they start sort of orbiting it. So they try to get pushed towards the thing. And again, the higher we make this suction force, the harder they will be pushed towards the thing. So something you can already see them sort of starting to already sort of move across the curve. Not completely because we haven't introduced the other thing yet, but we're getting somewhere. Right, so now let's also right, so we have our direction here. So let's also add this to our other thing. So let's also add, let's see where we're going. This is do it over here. So at force plus equals, let's say direction. Maybe over here, let's also make a multiplier thing here. So direction times times equals speed. All right, so we're gonna get a slider for speed. All right, let's press play. And oh, let's move our sphere thing again back to where it was. So it starts out on the curve. And all right, it's going a little bit crazy here. Probably let's increase the speed. Let's see how that does. All right, let's increase the suction. Yeah, all right. So now you can see with the suction increased here, it will stick to the curve. And again, like you can just tweak your sort of your amount, and we can build this out with some additional stuff. Like we have the curve view here, so we can do some interesting things. First, let's start. So this is the basic thing. We're gonna also tweak the look a little bit of these particles because this is already the basics that we have. Now let's add some additional stuff. That maybe we want to delete the points once they get to the end of the curve. Maybe we want to introduce some influence across the curve, like how much suction should be where on the curve, etc., etc. So let's start implementing that. Maybe first, before we do that, let's clean up our code here a little bit. Let's look xyz distance. So let's integrate stuff. I always, like, my code is always terrible. I never know how to name stuff. I always just drop down and whatever. So this integrate stuff, and this should be all right. Like, load stuff. All right, perfect. I should really just clean it up a little bit more. add to force. All right. We could also, like, instead of doing it like this, we could, guess it would make more sense to just do like this. So now it's going to move across the curve like that. Beautiful. All right. So we want to extract some more stuff. Maybe you should give it a better name, like extract attributes. Right. So let's also extract curve view. Curve view. All right. And I'm not sure which is the end of my curve. Let me just do a color on it. Ramp attribute curve view. Let's just have a look. All right, so this is 1 and this is 0. So we could say that, for example, we want to remove them if they are close to 0. So let's say do additional grab. All right. If curve u is below 0.1 or something, then remove point. All right. That's gonna move, la 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 la, moving across the curve with all my friends, la 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 la. Oh, and now we're getting deleted. So you can see we did some other stuff. Like you could do a bunch of things. You could extract colors from this curve as well. We could maybe, okay, so we have this suction. We could do additionally maybe that suction times equals, and let's do a ramp. Suction ramp and curve u. So curve u, why is it complaining about curve u? Oh yeah, we're this should be a float curve u. All right, so we could have a we could add some additional controls here too. I didn't even have that in my original thing, but you could, yeah. So on some pages, it will be slightly, suction will be higher, will be lower. You could add all kinds of things. We're going to add color a different way, but just to show you what's possible. Let's say we want to have a color ramp here. This is probably just going to look the same as an attribute transfer, but just to make a point. Just like if you're not familiar with this stuff, then it might make, like, then it's maybe interesting. CD equals CD. Oh, that's, again, it should be vector. Vector. All right, here we go. So now you can see it would add the colors from the, and again, this just looks similar to attribute transfer, but you kind of get the point. So, like, again, suction on some of these places of the curve is more, or it's a little bit less. I guess I'm just gonna, I think I just want it to be the static value again, but just showing you how you can do it. So I'm just gonna make the curve the way it was before. I'm gonna remove the color thing here. I am gonna add color to my sim, but I'm not gonna do it like this. What I'm gonna do is, I think, let's not scatter on points. Let's do on this thing points from volume, maybe. Oh no, let's not do that. Let's just do increase this thing, and let's do attribute noise, maybe. Call it, let's make it a float. Density, and let's do a color afterwards. Let's do rem from attribute and let's pick some fancy colors. All right, let's like blue and like blue and white maybe. All right. So, all right. Now we just have some colors. All right, so this is essentially the Curveforce. Now that's the base. And again, like just to point out, you can build this out with other stuff. So it would be similar to the Popcurveforce here with a whole bunch of things, which we're not going to do. But if you want a better Curveforce and you want a challenge, you can build it out however you want. But I've given you enough tools here to do that. Now let's just make our thing, like our pop forces, our thing here look a little bit better before we do any rendering or whatever. So yeah, let's add some interesting velocities. So I want to add some volume velocities. So I'm just going to make a volume. So let's do a box here. So let's do a box on our curve. So you have a box thing now here, and let's do a VDB. Oh no, just an empty VDB. Just call it. Let's make it a vector float. Let's call it vel. So there's going to be an empty velocity VDB, and then we're gonna VDB activate. So I'm going to activate, because VDBs are sparse, I'm going to activate them by the bounding box. Reference. So now we have our velocity in this thing. Of course, our velocity here is still empty, but we can do a volume VOP. And we're going to bind our velocity. I mean, you could also just use pop forces, but just affecting them by some volumes, even though it's not a volumetric sim, it just looks nice. This just makes it like a little bit more magical and stuff. So let's bind vel to vel, and let's do curl noise or something. So let's put position here. And you know what? We don't even have to do that like that. Let's just put it directly, like, because we didn't have any incoming velocity. So let's put curl noise. Let's promote all of these parameters. Something like that should be fine. So now we have some velocity here. Yeah, we fog volume, vector reveal, all right? Let's do volume slice. Let's slice the velocity and then do volume trail. So this is just visualizing the thing, and then we just put this into the velocity volume here, and then we're gonna say vel, and for some reason not working. Why? Let's position. Okay, we don't want to bind to density, and this. Oh, yeah, okay. We didn't have it plugged into the actual FOB. All right, that was just stupid. All right. All right, yeah, I know I always leave these mistakes in because that's what you learn from as well, so you don't have to make them yourself. All right, so yeah, we have a have some nice little curves here. You'll default. All right, let's make a null. And again, you could also just do pop force, and like pop forces are also essentially curl noises, but I just like with volume advection, it just looks a lot nicer. So just copy that out thing. Right. Let's go back into our network here, and let's do pop advect by volumes, and let's put it in there. Swap Curveforce and treat as wind. All right, let's have a look. Okay, I'm not necessarily happy with the way that's looking yet. That's a little bit extreme. All right, that's maybe a little bit too. Let's do a little bit less air resistance. Let's reset simulate. Let me just link my viewport to the second thing, so we can just work in here and then just like that, right? All right, yeah. Oh, that's a little bit too much. Yeah, so we're just advecting them with the velocity VDB. So now we're gonna have them sort of move. All right, so this may be a little bit too extreme. Let's, by the way, name this thing Curveforce, right? And let's maybe increase the, it's down here, let's increase the speed. Yeah, so it's moving towards the thing. Could maybe decrease this thing. Maybe decrease it a little bit more. Don't want to spend too much time tweaking this, but oh, you can see a couple. They're not necessarily, this is not necessarily wrong, because what happens is they're sort of like they get dragged into the other part of the curve. So that's not necessarily a bug. That's just they get dragged. You can see they move too much towards the other side. I guess you could technically account for that with the curve U attribute if you really wanted to. We're not going to do that for now. So I guess like something like this. Maybe add some additional pop forces here. Pop force. Pulse length is the length, so the higher this is, sort of that's the time. I think it's in seconds. So if it's 3, it will move through the noise pattern in 3 seconds. So we can just stack some additional pop forces on top of these. But looking pretty good. So let's just call this like, we like this, we want this, so let's do final sim. If you want to do this, you really need to crank this up like really high. You need a ton of points. So I'm not going to cache this out again because this is going to be a very big cache. So for the part now, we're just going to render this. I'm just going to use my previous cache that I had, but again, if you can also just download this file and just play around with it. And again, if you're a Patreon supporter. But like you really need a lot of points for this to look good. So just crank it up, put it on some caching disk somewhere. Yeah, so let's cache it out. I'm just going to go back to my original example here. I'm just going to grab the file cache. But before you cache, by the way, let me just grab that thing. So I'm just going to use my previous cache. Before you cache, because it's going to be big enough already. If you have a look at this stuff at the pop network, let me just put it on. By the way, before you cache, of course, if you use $job, make sure to set your project to wherever it is you want to set it. But these particles will have a lot of attributes on them. So air resist, dead, density, has previous, blah, 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 which you don't need. So you can see this is now 48.19 megabytes. So you put an attribute delete and put a star and then just this thing and then whatever it is you want to keep. So I only want to keep, all right, so I did the color before here. So I'm going to remove the color here because the color is a vector. So that takes up a lot more space than just the density. So I'm going to keep density here. I'm going to remove color from this thing. All right, it's not there. So I'm going to keep the density. I'm going to keep the velocity because we want to have motion blur. And I want to keep the ID because I want to be able to retime this thing. Because maybe you want it to be slower and we can just do that after the fact. So if once you remove all of that, so let me just play through a couple frames here. So if you look here, almost 90, so 89.51 megabytes, and then here 50. So saves quite a lot, especially if you have a really long simulation. So here I have my original thing. So this is density attribute on it, and then we just copy and paste our color again that we made, and then it's gonna do the color thing after the fact. Because if we were to do this before we cache, then it would be a lot bigger. So let's say if we do it over here. Oh, all right. So let's say over here, 54.65 megabytes, 68, because it's a vector, so it needs 3 times as much storage. So let's do it after the fact. So yeah, make a file cache, cache out your thing, and then you're gonna have a little thing here. So with the little thing, let's do the final things. So let's retime it a little bit and then do the rendering. So let's first give them some alpha. Maybe let's do background, by the way, in dark. So if you press D in the viewport, and you get this thing. So press D in the viewport, make it black, and then you can make a wrangle here. So let's set some alpha. So the default attribute here is alpha. So let's say if you say 0.5, then it would be a little bit transparent. It's not too easy to see if you do it like this. It's a little bit easier to see. Like I have a ton of points here, by the way, 10 million. I don't want to do that. What I want to do is I want to do it based on the how fast they're moving. So they kind of, the alpha changes a little bit. Like if they're moving faster, the alpha will increase. So if they're fast moving, they will get a little bit thicker. That's kind of, you could, like, you don't have to do this, but I mean, why not? So let's do float f equals, let's say, the length of the velocity. So this will set the length of the velocity. So if we were now to say, for example, cd equals f, you can see how faster they're moving. You could also color them, by the way, based on this if you want. But you can see this already looks kind of cool. You could also, yeah, we could also render that, but I'm going to use that to set the alpha. So I'm just going to, like, you can technically calculate the min and the max values. I'm not going to do that now because we need to attribute promote, blah, blah, blah. I don't want to do that. So let's just have a look roughly what the max values are. So roughly around 2. So you would say f equals fit 0, 1. Oh, no, fit, sorry. And not 0, 1 because it's not 0 to 1 yet. So I want to fit f between 0 and 2. And then, and then want to fit them to 0 and 1. So now we have a 0 to 1 value here. So if we were to set cd equals f, for example, then this would be roughly between 0 and 1. Yeah, it's a lot of points, so it might be a little bit slow sometimes. So not exactly, but roughly, because again, if we wanted to be perfectly between 0 and 1, then we need to calculate these things, but it's roughly okay. So you could just say f at alpha equals general ramp alpha f, right? Whoop, get a little ramp, and then want to maybe do a multiplier thing. So again, times equals let's multiply, right? Bam. There we go. So yeah, some alpha, and then you could, again, probably want a little bit of a minimum thing, and then we could, what did I have in my original? In my original, let me just, I'm just looking over to the right because there's I had something like this. So, and again, just do whatever it is that you want to do. I mean, it doesn't need to be exactly the same. Just make it whatever you want to make. Let's do a p-scale because it's going to be used for rendering. You could randomize this. I'm not going to do that because you're not going to see it because it's going to be tiny. The scale, let me see what I had. Oh, they're really tiny. 0.001. So this is going to be the size at which, 1020, 0.001. It's going to be the scale at which they're rendered. So easy enough. Now let's sort of retime this a little bit, I guess. So let's first say maybe a minimum thing, because else it's going to be a little bit long of a render. So let's do time shift. Let's say add a couple frames to this thing. So then at frame 1 here could already be here. Now let's do time blend. And let's speed. And let's do like 0.33. Or maybe... Oh, is it... Are you doing things? Or are you not? Alright, there we go. Yeah, it's a lot of points, so it's not the fastest thing ever. And why are we not seeing the alpha work? We could do the alpha just after the fact. Then it doesn't need to calculate the entire thing. Right. So then we have this stuff, and it's a little bit slow because of the retiming and it's just being a lot of points. You know, you see 18 million points. But we have this stuff. Now I already made a camera, but yeah, just make a camera. You should probably, if you've watched this tutorial, you should probably know how to make a camera. Else, if you're not, you should have watched Houdini 101 first, my beginner course for Houdini. Right, so let's just make an output thing. And let's render this. So let me just remove this thing. So in order to be able to do additive rendering, and we're gonna do this in Mantra, by the way, but the like the additive rendering that we have here. So additive rendering is where, like, if there are multiple sort of particles stacked on top of each other, they will like give this nice additive effect. So if it's like a thicker part, then it would like be thicker. Easiest way just to do that in Mantra is here. You can see I already have one, but there's a glow shader on the utility. You just put it in there. Essentially that does additive, and it's just sort of an additive material. So we can just add that to our thing. So again, like my old glow was already here. So this is glow 2, I guess, because this one from the tutorial. So we just add it. So it already has some stuff. So tint with point color, because we want to do is we have these point colors, right? Use point alpha. We also want to do that. Then we have the glow ramp and the emission. And like in my original had it like this, and we want to enable emission. But let's first go to our render view, and let me make a new Mantra node. Right, Mantra, and let's press render. Take a little bit to start up, but once it's started up, it's gonna be pretty fast to make changes. So let's just wait. Oh, I should probably, in case my, where is that again? I want to turn off a couple of cores. Where is that again? Don't use Mantra that much, so I'm always looking around these things. Normally I use a little Redshift. Where is it again? All right. Use specific thread count. Let's do 16 threads. All right. Right. Let's see if this hopefully records properly. All right. So I just stopped recording and double checked real quick if the recording would continue properly, because I don't want to continue and then have my recording break because it's completely cranking all my cores. But now I put it to half of my threads. So yeah, you can see this is the thing, and like it's like Mantra is generally slow, but for like particles, you can see this is really fast. And this is using half my. I have a thread ripper. And now this is set to using half my thread, so this should be pretty basically like the same as a mid-range Ryzen. It's already 9020 by 1080, so you could change some sampling size here to like increase the thing a little bit. Probably want to do motion blur. I'm just going to put the pixel samples back, by the way. So want to allow motion blur. And then in order to set motion blur, we also need to go to geometry, go to render, and then go to sampling, and then velocity blur. So now I need to think a little bit because now it also needs to extract the velocity, but now it's also going to do the motion blur. And yeah, this is essentially, oh, and one more thing, by the way, that we need to do on our glow. Let's enable emission. So now you can get this, like if you enable emission, you get this nice sort of additive thing here. So this is where it will like, if they're stacked on top of each other, it will sort of emit more light. And you have the glow ramp rate. You can see if you increase it or decrease it, you can get your thing. And then we could alternatively also still tint this a little bit if we wanted to. So I could add like a little bit of a different color to it. So yeah, I think this looks pretty cool. This is essentially what I made. Yeah, that's essentially everything there's to it. So you can just say your images, like just put a render direction like / my particles $4 4.exr. And you just render it out. You can here in extra image, you could put components, but don't necessarily need that here. And then all of the other stuff, like I had some light rays and stuff. I did all of that in compositing, so that doesn't have anything to do with the final thing. So yeah, then you're done, and then you have this awesome effect. So again, like these light rays here, that's just a comp thing, and this star glow here, it was also just a comp thing. All right, so that was the entire thing. So yeah, hopefully this was useful. Again, like you can just play around with this and like expand on it, build your own custom tool. But hopefully you can see sort of how this can be beneficial, because now you also have full control for this thing in Vex, and you can add functionality on top of this, and then hopefully have a little bit more control than the regular Popcurveforce. So hopefully you picked up some interesting techniques, stuff that you didn't know. If you did, please leave this a thumbs up. If you didn't like it, then leave this a thumbs down. Still helps out for the YouTube algorithm, so doesn't matter either way. I like seeing thumbs up though, so that's nice. If you want to see more of these videos, I upload pretty regularly. You can subscribe to the YouTube channel. If you want to help me make more of this stuff, you can subscribe on Patreon, and then you can also get access to the downloads. For example, I put the downloads to all of my tutorials and stuff are all on Patreon, so you can download everything there. I have a ton of exclusive tutorials there as well. If you just want the files one-off, you can also get them on Gumroad, so link to all of that will be in the description. Yeah, thanks for watching. Hope you learned a lot. Leave a comment if you want to chat, and if you want to get in touch any other way, you can also do that on my Discord. I have a Discord thing. You can send me an email. Do whatever you want. Anyway, thanks for watching. See you in the next one. Peace.